Process mapping, a process approach to quality. The basic workflow of a laboratory may be broken down to input, process, and output, where input is the specimen and output is the report generated. The actual process is further broken down to pre-analytical, analytical, and post-analytical processes. What is a process? A process is defined as a series of steps which convert one or more inputs into one or more outputs. What is a process map? It is a pictorial representation of the sequence of actions or series of steps that make up a process. It traces the flow of physical product and information through the steps. If there is no physical product, the map is used to document the step-by-step activities involved in providing a service. Why process mapping? It is a quality tool for improvement as it helps to identify the critical points. It helps to identify the focus areas for root cause analysis. It helps to delineate responsibilities. It identifies gaps in processes and provides a framework to base SOPs and work instructions and for assignment of job responsibilities. Symbols used to process map. There are many symbols that are used to prepare a process map. The four most important ones are given here. At the start and end of the process map, an oval is used to show the materials, information, or action, that is the inputs, to start the process, or to show the results at the end, that is output of the process. A box or rectangle is used to show an activity or task performed in the process. Although multiple arrows may come into each box, usually only one arrow leaves the box. Any decision to be made is depicted by a diamond, which shows those points in the process where a yes or no question is being asked or a decision is required. A circle with either a letter or a number identifies a break in the process map and is continued elsewhere on the same page or another page. To compile a process map, write down the name of the person performing the task and the task which has to be performed. Essentially, who does what and when. Process bottlenecks. When compiling process maps, you may come across process bottlenecks. It occurs when a step is the limiting step of the process. This step takes a significant time and slows down the whole process. An example is a functional bottleneck like a single centrifuge that is needed in multiple processes, which may then hold up and slow down all the three processes as they queue up for their turn. Value or non-value adding steps. Value adding steps are the activities which transform the inputs and moves them towards the next defined outcome. This activity is something that the patient cares about. Non-value adding steps or waste do not serve any purpose. Aim to remove these from processes. Necessary non-value adding steps. They do not directly benefit the patient but are necessary. Example, completion of forms, logging patient details onto systems, and checking of details. Waste or non-value adding step is a sensitive issue. It is critical to recognize that the non-value adding activities may have been a core part of someone's job for many years. When non-value adding activity is identified, care must be taken to ensure that the individual employees do not see that as a criticism of them. It's the activities that are non-value adding, not the person. A few examples of waste or non-value adding steps in a hospital are confusion, motion or conveyance, waiting, overprocessing, inventory, defects, and overproduction. Analyzing the process map. After compiling the process map, the next step is to analyze the process map. The analysis involves asking these questions. How many steps are there in your process? How many duplications? How many handoffs? What is the approximate time of or between each step? What are the possible delays? Where are the major bottlenecks? How many steps do not add value for the patients? How many types of waste are there between each step? Where are the problems for patients and staff? Following analysis of the process map, two important steps which might have to be taken are RCA and CAPA. RCA stands for root cause analysis and CAPA means corrective action and preventive action. The corrective action needs to be taken to eliminate or fix the gap or non-conformity which was detected during the process mapping or quality assessment. After the corrective action, preventive action needs to be taken to prevent the non-conformity or gap from occurring again. The 5 steps of CAPA are to identify, investigate, and analyze potential causes of non-conformance of product, processes, and quality systems. To identify actions needed to correct and prevent recurrence. Verify or validate the corrective and preventive actions to ensure its effectiveness. Implement and record changes in methods needed to correct and prevent identified quality problems. Submit information on CAPA for management review. RCA or root cause analysis helps to identify, document, and eliminate the root cause of a problem or non-conformance. A few examples of errors or gaps and possible root causes are listed below. Sampling errors could be due to shortage of staff or disengaged staff. Technical errors while testing could be due to absence of protocols, absence of training, or could indicate improper monitoring or supervision. Near-miss events or clerical errors could be due to absence of checks and balances. Once the root cause is identified, relentless work is needed to eliminate it. RCA of a failed test run. A popular technique used for root cause analysis is to prepare a fishbone or ISHIKAWA diagram. Here, the factors involved in running a test are put down as the spokes of the fishbone. As seen in the image, personnel, procedure, reagents or supplies, equipment, and environment are the factors influencing a test run. In order for a test run to fail, each possible cause under these factors are listed. For example, problems affecting the personnel can be due to inadequate training, multitasking, inadequate staffing, and overworked staff. The issues with the procedure could be due to lack of clarity in SOP, suitability of the specimen for the procedure is not defined, invalid or inadequate procedure for the intended use. Problems affecting the reagents or supplies can be due to expired, contaminated, or wrong lot. Issues with the equipment may be mechanical failure due to no maintenance or out of calibration due to wrong calibrators. The environmental factors leading to a failed test run are environmental contamination due to inadequate or irregular cleaning, lack of SOPs for decontamination, or poor ventilation and temperature control in the room. Preparing a fishbone analysis will guide you to identify the root cause of any gap or nonconformity. Some basic techniques to be remembered while redesigning a process are: eliminate non-value adding activities, eliminate duplicate activities, combine related activities, identify and remove wastes at each step, process in parallel, use decision-based alternative process flow paths. That brings us to the end of this session. Thank you.